So the first one is you have your mass and it's hanging from the ceiling, and I say that this angle here is 40, and I say that this angle here is 50, and then here there's a force of 50 G. So what you need to do here is this is T and this is S, or at the other end of the string this is T and this is S, or T1, T2. So in blue, here's the blue, this is T cos or sine? Cos, and then here T sine. What's wrong? That's a 50. Yeah. Now, if you want, you can use this here as 50, and this one here as 40, if you want. You get the same answer. Yeah. Okay, and this one here is S cos 50, and this one here is S sine 50. Okay, so I can make, I can say T sine 40 must equal what? Anyone get that? S sine 50. Because this is me saying the right must equal the left. Okay, and then here I can say T cos 40 plus S
cos
must equal 50G, yeah. And this is you saying that the up must equal the down. So are we clear on how I make these two equations? Only two.
The second one.
Yeah, the up forces equal the down. So, oh sorry.
I've seen that.
How about I drew it upside down? I should have drawn my vectors. Guys, I should have drawn them here. Yeah, sorry. So anyway, so the same numbers. This one here is T cos, and this one here is S sine. You know what? I'll draw it again, but don't worry if you have it drawn. Okay, I just want to draw it again. All right. This one I said was T. This one I said was S. What did I say? This one was T cos. Was it? T sine 40. And this one here, T cos 40, S cos 40, and here S sine 40. Now some people maybe use this, which is fine. Did anybody here say T cos 60? If you did, that's okay, it's the same. What did you say, KJ? Did you use sine 40 here or cos 60? Okay. Really? That's okay. Alright, so Clara, so your question was, how did I get the second equation? So here, what are the up forces? T cos 40 plus S cos 40 should equal 50G. Yeah, and then what's the force left? T sine 40 should equal
T sine 60.
S sine 40. Yeah, this one should equal this one. Okay. So you have sine 40t minus sine. What's that? Oh, for goodness sake! Sorry, children. That should be 50. I wrote it wrong. So here, that should be 50. Okay. Yeah, I need to change this
50.
should be a 50.
Yeah.
Alright, and then
Equal.
sine 40t minus sine 50 s equals 0. So this is my first equation, this is my second equation. I just rewrote that first equation down here equal to 0. Now let me just put in the numbers. Cos 40 is, okay, so you have here 0.766t plus cos 50, 0.643s equals 50g. 490.5, and then in this equation, sine 40, so you have 0.643t minus 0.766s equals 0. So this is what I wanted, two equations like this. What method should I use to solve this? Which method do you like? Anyone?
Mechanical method.
Huh? What's that, Karar?
Equal one. Yeah.
You could eliminate. Yeah. So I'm not going to do that because we did that in math class. I'll just get the answer.
Very quick.
So when you solve these, you'll get T equals 376 newtons, and you get S equals 315 newtons when you solve them. Using whatever method you want. Elimination, substitution, Gaussian even, whatever method you want. Okay. Sorry about my picture. I hope it's okay. Did you get this right? Good job. Okay. So I think actually most people got the first one.
Yes.
Yeah, just the first one, which is good because that's the most common one in the exam.
I'm happy with that.
So that's good news. Right. Let's have a look at number 2. Can I scroll down?
Yeah.
So in number 2, what you have is 12 kilograms, and there's 2 1-meter strings. And the rod is... Oh, I don't tell you, do I?
No, it's 1 meter long.
Oh, it's also 1 meter.
Yeah, but the strings are not.
Yeah, the strings are 1 meter as well.
Yeah.
And here is 12G. And there's a force here, and there's another force here. Now I actually know that they should be equal because it's symmetric, but I'm not 100% sure. Where do these forces all meet? They all meet right here, at the sea level. Not only that, you actually know what this angle is, and this angle, and this angle. Why 60s? Because it's a 1-1-1 triangle.
Yeah.
And what am I looking for here? The tensions. So again, what you can do is you can say that this one here, how big is this one? T cos 60, and this one here? T sin 60, and then this one here?
T cos 60.
S cos 60. Well, I'm not going to just because they're not always going to be nice like this, so I want to do it if they're not equal. I know in this example they are equal, but they're not always going to be, so I'm going to make them a different letter. S sin 60. Okay, so maybe Karar actually, can you tell me the first equation when you say the forces to the left equal the forces to the right?
That's so okay. T sine
T cos.
T cos 60.
Yeah.
Equal.
Yeah.
S cos 60.
Good, okay. And then Yemi, can you give me the equation for the ups and the downs?
S sine 60.
Yeah, S sine 60 plus T sine 60. Yeah, equals 12G. Yeah. Yeah? Did you get something like this?
I already made a mistake on the diagram.
Okay, good, then that's a problem. So cos 60 is a half. So this first equation is 0.5t minus 0.5s equals 0. And sine 60 is 0.866. So you get 0.866s plus 0.866 t. Sorry, I should write the t's and the s's together. 0.866t plus 0.866s equals 12g. Now what's very nice here is you can divide this equation by what? 0.5 and divide this one by 0.866. So it makes this very nice system. T minus s equals 0 and t plus s equals? No, don't forget to divide by that number. So you get 135.9. All three of these get divided by that. So, when you solve, that's actually easy to solve. You get t equals 67 68. And then, s will also equal 68.
67.95.
Yes.
Q or 2T?
One thing.
T or 2t? Oh, I did it in my head, sorry. So like, I added these together to get 2t, and then I divided by 2, and I got the answer here. Yeah, and then here's s. Yeah?
If you know they are equal, you can use different method.
Yes, you can, yeah, but I did it the long way because they're not always going to be equal.
Because you know when you see a diagram, it's 1, 1, 1,
Oh, yes. If you want to take this shortcut, that's fine.
I did that.
Will
Good.
it add more marks and see the long there?
No, it doesn't. I'm just doing it so you can see it. Can I go down?
Yes, please.
Yep. Okay.
Tell me more.
The cylinder.
I think that.
I'll tell you what I'll do. I'm going to draw number 3 and number 4, but I think I would like to leave it for you to try again, and then I'll do them on Friday class. Okay, so I'll just draw them. Number 3 looks like this. This is 40, no, sorry. This is 4 centimeters. And then you have a big, hold on. Yeah, hold on. Then you have a big cylinder here. E and D is, and then this here, its radius is 10 centimeters. And what's happening is there is a force here. Sorry, that's ugly. I need to draw it bigger. Okay. And there's 10 centimeters. And there's a force here pulling it to the right of F. And there's also a force going down. How much is this force? 10G. Now there's one more force I didn't draw. What force did I not draw?
The reaction.
The reaction here. And I know exactly where that points. Where is it? exactly to here.
Okay, so we have a angle.
Now, sorry, can we see here? Let me give you a little help here. If I draw a triangle here, sorry, how big is this? Guys, look up, how big is this?
10.
10. Now, if I draw a line across to the wall, how big from here to here?
10.
No, from here to here is 4. So how big is, I know it's not right. How big is this one?
6.
Should be 6, I know. Now, how big is it from here to here? If I draw a triangle? 10, because it's the same as this. So this is 6 and this is 10, so you can use Pythagoras here, it'll be 8. So do you know this angle? Yeah, you can know it. So I think you can finish it now, and I'll do it on Friday. And then in a moment I'll draw the picture for number 4.
What was the point F, yeah?
Yeah.
Yeah, and what was?
Can I scroll down? Yep. Okay. Number 4 looks like this. You have your wall. You have your ladder. How long is the ladder? 10 meters, and it's 20G. There's a reaction here, and then there's a reaction here. But you know that they all meet. So if I draw this line across here, and if I draw this line up here, and I draw this line up here, they all meet right here.
Yeah.
Okay. So, distances. How big from here to here?
4.
Oh, sorry, yeah, I didn't actually say, did I?
You said total is 8.
I said the total is 8, so this is 4 and this is 4. And how much is this one?
5.
5, and here? 5. And then from Pythagoras, this is a 10, this is an 8, so this will be a 6. But if I split it, it'll be a 3 and a 3. Okay, so now actually that's pretty much it. I guess I didn't need to do all of that. But how big is this?
3.
No, in total, sorry. 6. And how big is this? 4. So this angle here is tan inverse 6 over 4. I did much more than I need to. Didn't actually need to get all those distances, but I'd like to. Actually, no, maybe the distances might be helpful later. So, here to here is 5, here to here is 5, here to here is 4, here to here is 4, here to here is 3, here to here is 3, here to here is how much? 4. What about here to here? 3. Yeah. Yeah, I could. All the distances are there now. Every possible distance you could need. So I think you can try it now. Yeah? Alright. So then on Friday, we'll do those 2. Now on Friday's class, I'm not going to redo this part, okay? So I'm just going to use the diagram that you drew immediately. I won't explain this again on Friday, okay? Do you think you can try that again for Friday? Yeah? Alright, so let's have a look at the first lesson now.